Section 10.3. Our objective today is I can state and apply theorems involving concurrent lines. So first of all, let's define what we mean by concurrent lines. Concurrent lines are lines that intersect in one point. Okay, so these would be concurrent lines because they intersect at this one point. But the concurrent lines that we are going to talk about today are lines that we get from different constructions that we do. So our first theorem has to do with angle bisectors. And it says the bisectors of the angles of a triangle intersect at a point that is equidistant from the sides of a triangle. Okay. So we've been talking about bisecting angles, and I don't have a compass that I can use on here, but basically if we bisect the angles of a triangle, those angle bisectors are going to intersect at one point. And the distance from this point to the sides of the triangle is the same distance. Okay, so that gives us this could be the center of a circle, and then we could put a circle inside it. It would touch or be tangent to the sides of the triangle. So the angle bisectors give us a point equidistant from the sides of a triangle. Okay? So that's from bisecting the angles. Our second theorem has to do with the perpendicular bisectors of the sides. So it says the perpendicular bisectors of the three sides of a triangle intersect in a point that is equidistant from the three vertices of the triangle. Okay. Now, depending on the type of triangle, these lines may be concurrent inside the triangle, outside the triangle, or on the triangle. So for instance, if we look at a right triangle, and we do the perpendicular bisectors, okay, then this point is going to be equidistant from all three of these vertices. So if I use this point as the center and this distance as my radius, I can circumscribe a circle about the triangle. Okay? So the perpendicular bisector of the sides intersect at a point, and that point might be inside, on, or outside the triangle. Okay? The next theorem. It just says the lines that contain the altitudes of a triangle intersect in a point. Okay? And again, that point might be outside of the triangle if we're talking about the altitudes, or it might be inside, or it might be on. Okay? And our final theorem, it has to do with the medians of a triangle. So first of all, remember that a median is a segment that goes from a vertex to the midpoint of the opposite side. Okay? Now, when we do the medians of a triangle, those will always be inside the triangle. And the theorem says this about the medians. It says the medians of a triangle intersect in a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay. So basically, so we have some triangle, and so let's say that this is the midpoint of this side. This is the midpoint of this side. And then this is the midpoint of this side. Okay? So they are concurrent at this point. And so what the theorem says is from the vertex to this point, it says that is 2/3 of the distance from the vertex to the midpoint. So this distance from the vertex to the the concurrent point is 2/3, and then this distance is another 1/3. Okay? So it's saying, let's say this is point A, this is X, and this is point B. Okay? So if AX has a length of 6, then XB has to have a length of 3. Okay? Because that gives us 9, and 2/3 of 9 is 6. Okay? So again, from the vertex to the point of intersection is 2/3 of the distance, and from the point of intersection to the midpoint is 1/3 of the distance. Okay? And so in class, we will do some of these constructions and see what happens with these. Okay?